Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid. I love that word.
Hello and welcome to Diffusion. Sit back and relax while we invigorate your brain with weird and wonderful science. I'm Ian Woolf. On this edition, entomologist Shasta Henry makes a butt sling for a clown beetle, performs science communication, explains giraffe beetles parasitising wasps, and how to identify insects with Google. Shasta Henry is an invertebrate ecologist, entomologist and biogeographer doing a PhD at the University of Tasmania. We spoke by Zoom, and there are some noises that sound like insects chewing that I couldn't get rid of. We continued our conversation by Shasta showing me her little friend.
Got a little friend here. Go to this is just proof for the get people to go to the website, and I'll try and get it. And I feel like a beauty blogger when I'm doing this. I'm holding upwards one of my favourite specimens, which is a very, very shiny, smooth black beetle. If you get on the Google machine and look up clown beetles, this is a beetle from one of my favourite places in the whole world, is White Sands National Monument in New Mexico, where a friend of mine grew up. And it's got its rear end stuck right up in the air. They're actually called clown beetles because they kind of assume this sort of handstand somersault position. And this is a defensive position because the beetles have got a chemical spray. And so they spray this noxious chemical, and that defends them from sort of most things that would be interested in eating a beetle. And so they live in this white sand desert. They're pitch black. They haven't had to evolve any kind of camouflage. They haven't had to pale out their coloration at all. They're able to live as a really conspicuous part of this landscape, which for me is great. It's super easy to find and go and take photographs of because they're just boldly walking across the sand in this really high contrast. But I found this one outside of the National Monument at a friend's house, and I collected it. And its noxious spray stained the ethanol that I collected it into bright purple. So it was really virulent. But when I got it back to the lab and I decided to pin it out, dry it out, and turn it into a specimen, like all of the specimens that you see in the drawers at the museum. And so one of the sillier, funnier things I've had to do that comes to mind in my profession is to make a butt sling for a beetle. And so they dry hard when their exoskeleton all dries out and they hold their position. But when they're wet and when they're fresh, they're all floppy and they need, each little foot needs to be held down by a little tab of paper, and every knee needs propping up with a pin so that it, everything faces in the right direction. When you see those really beautifully presented insect specimens, there's so much work that goes into that, making sure that they're all at right angles or, in the pose of walking or whatever the presenter wanted. And so to hoist this clown beetle's butt up into the air, I had to devise a sling for a beetle abdomen to hold it up. And so, some days people ask you, what have you been working on? And sometimes that is the answer, making a butt sling for a beetle.
That's terrific. Do you want to talk at all about some of your science communication work?
Yeah, I love being a science communicator. It came together, as all of my stories apparently have, a number of different puzzle pieces. I mean, that's the way the world works. I used to work in tourism before I started at university, and so my kind of first profession in the natural world was working as a rock climbing and a whitewater rafting guide. And I thought that was lost time. I thought that when I came to university and I started studying and being an academic, that was all sunk costs, and I'd lost all of the things that I had done as a raft guide. But it was fun coming into the classroom and learning names for all of the natural features that I had observed out in the natural world. And so all the different pieces of grasses that I had sat on the edge of rivers, pulling up. So it felt complementary to never looking backwards until TED Talks and then science communication started to become more prevalent, more common. Scitainment, people were interested in it and wanted to hear this stuff translated for them. And I discovered that all of that time standing in front of people and entertaining them on trips and giving them safety briefings about how to do up the buckles on their life jackets might finally have a second wind. And I had an opportunity to bring back together all the time I had spent talking to people and all the time I had spent learning about invertebrates. And it also dawned on me that living in Tasmania, a small place, and working in entomology, a small field, I very well may have to employ myself to have work. And so science communication is just kind of one of the easier access, or it was for me, I suppose, with the skill set that I had already. It was one of the easier access ways of basically being a kind of a consultant entomologist, but I can do it on, practically any subject I decide to Google up, to be a consultant ecologist. I need that PhD and I need experience in specific fields, whereas to make an engaging YouTube video or to go and talk to a classroom of primary school students, I only have to be better at entomology than a classroom of primary school students. And that just sounds like temptingly low-hanging fruit to me. It's also very nourishing. Academia is a really hard slog, and just even if it's super engaging, which I'm still really into my thesis subject, you spend a lot of time drilling right down. You spend a lot of time on your own, focusing, learning at the really pointy end of things. And that's not very interesting. Dinner time conversation, it doesn't change much your personal landscape. And so your partner, tunes out. You do the same thing over and over again. And so to kind of put myself into a classroom of students through, for instance, the University of Tasmania has a National Science Week initiative called Young Tassie Scientists, where thankfully a scientist wrangler at the university gathers us up and gives us a timetable and sends us out into school classrooms. And so to have an audience that has really broad spectrum, really weird questions that I have to be prepared to answer and who are really excited that I'm there is just a great way of zooming out, getting a bit of light and sunshine into the kind of the dusty academic space. And so I find it a really, really rewarding sort of two-way street. People apparently want to know the things that I know about insects and things that I stopped thinking about a long time ago, like the difference between a bug and a beetle. It's like, off the top of my head, you go to a conference with entomologists, nobody's talking about that. But 7-year-olds think that it's super fascinating getting to tell their parents, no, that's a lady beetle, not a lady bug. Don't you know? And so, they want to know what I have to say, and I am just thrilled to be speaking to real people who are excited that I'm there.
It's funny all the things you can see. I saw a question about cicadas on Twitter this morning, asking about why they go quiet when the clouds come over.
I don't know for certain, but I'm always happy to have an educated guess, and seeing as the society has invested so thoroughly in my education, I feel like I am qualified to make educated guesses. So knowing that insects are solar powered, humans make warmth for ourselves. We burn food energy and we keep ourselves at a kind of homeostasis where we're comfortable. So we shiver if we get too cold, we sweat if we get too hot, and those are systems that help us warm and cool ourselves. But insects don't do any of those things. So they're very energy efficient. All of their food just goes into moving around and growing energy. But that means that they require the sun or the air temperature, both, to warm them, to give them enough energy to actually get up in the morning and fly. So there is less insects active at night, less insects active during winter. So as a very long preamble, the cicadas might be going quiet when the sun goes in to be energy efficient. It could be as simple as that. It might be much more detailed. They might know that if the sun goes away, they might not have enough energy to fly around. They're calling to try and find a mate. So if your mate is cold and doesn't have enough energy to fly to you, then it would, as a second step in that same logic, make no sense to call to them at the time. You can probably Google it though. I spend so much time Googling questions that I think up about insects or Googling the answers to other people's questions, which I periodically, bleed into my inbox, and I go, wow, that is really interesting. And I have no freaking idea. So I'll just, I have a secondary degree in invertebrate Googling.
I'll have to try that, because I mean, the other question that I had myself is, if I fly my little toy drones, the bees get attracted. So in midair, the bees will come up on the drones, and I don't know if it's the sound or what it is, or it's in their territory. But I was just wondering if you'd have an educated guess.
Ooh. I've obviously drawn a complete blank. I'm thinking
That's
about
all right.
it. It is really interesting, and I salute you for having observed that behaviour. Yeah, it could be the humming. It could be the foreign object. Bees can get a bit, but beekeepers, interestingly, and kind of obviously, probably have, other than bee specialist entomologists, beekeepers just have this massive, and very long historical wealth of information. Probably before bees were being studied as an invertebrate, they were being tended to as a captive, as a semi-domesticated animal. And so that's interesting from that kind of almost anthropological point of view, but this massive data set from kind of a non-scientific origin that is incredibly valuable. So yeah, I'm always ready to defer to apiarists when it comes to honeybees.
I will have to find an apiarist to forward my question to.
Yeah.
You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Well, you talked a little bit earlier about the pretty insects.
Yeah, I love the way they look. I love the way they do things, and the ugly. I mean, there's insects. I think they are beautiful. I mean, they've got colours, particularly. I think is really kind of undeniable. A person might not be super into the whole six-legged creepy crawly thing, but iridescence is just wired into the monkey brain to be really attractive. You might not love diamond rings, but everybody likes shiny rocks and rainbow sparkles. So I think that's just kind of in us. Beetles are my absolute favourite group of insects. Number one, insects are the average earthling. The average earthling is an insect. That's how many insects there are on the planet that we share it with. And the average insect is a beetle. So there are just so many beetles, millions and millions of them. And so there is a 1,001 different sizes and shapes and colours. I also like that they can be the same thing, but whilst also being so different looking. You get beetles, like we're familiar with staghorn beetles that have got the big mandibles out the front, and rhinoceros beetles with their great horns. They're so shiny and kind of architectural. But you might probably never heard of the giraffe beetle from New Zealand. You can go Google that later. So they've got a really elongated neck section. So they've got this kind of normal little small beetle body and this kind of normal little small beetle head, and then this enormous neck, which just makes them look so weird. And I think that's dead cool. But like I said, I've got the unfair advantage of having the attention of people who love insects and who hate insects. Insects kind of have that same hold over me. I love the ones that are beautiful. And I have this kind of morbid fascination with the ones that are totally awful. like parasitising wasps. Have you ever opened your screen door on your back shed, or pulled a piece of skirting board off, or opened your power box door, and you've disturbed a bunch of mud cells that are full of mummified spiders? Well, that's got less to do with spiders and more to do with parasitising wasps. That's not spiders hatching inside a special spider pot. They were put there by a parasitic wasp that has gone out, found them, stung them, paralysed them with its sting, and at the same time injected an egg inside of the not dead but paralyzed spider. And then the female wasp seals that spider up inside a mud cell for her baby to hatch out either on the outside or on the inside of the spider. And it's there as a fresh piece of food for that spider, for that wasp grub to feed on and then hatch out as a fully fledged female or male parasitising wasp to make more parasitising wasps. And that is just creepy. That is 100% gross and weird, and also very cool. When I find out stuff like that, I'm in two minds, because it's really gross and cool, but also as a liaison between invertebrates and the public, I just have to think sometimes, is like, could you just simmer down? Because I am trying to do some positive press, and when you do creepy stuff like that, it's just really hard to, like, I'm doing my best. If you guys could also just stop being so weird and gross, that'd be super helpful.
It makes insect diplomacy very hard.
Yeah, but they are just absolutely alien. They are, everything that we try to put into our horror movies and our, and our sci-fi. It's happening in microcosm down here on Earth already. So much weird stuff going on that we just don't notice.
Reminds me a little bit of those zombie ants, if you know the story.
Oh, you might have to tell me. I hear about this kind of stuff.
Well, I think there's a couple. So the zombie ants that I remember, there's a fungus that parasitizes their brain and sort of puppets them so that they climb up to the top of a tall stalk of grass, and then it sort of blooms and the spores go out and fall onto other ants. And there's something like that.
Yes. I do know about that. I can't think of the name of the fungus at the moment, but yes, it does that to ants, and that's quite possibly a very, very close kind of pest, pathogen, and host relationship, because it's actually quite hard to live inside another thing. Often, like, those parasitizing wasps will only attack one specific species of spider or beetle or whatever they prey on, because you've got to be super fine-tuned. It's like having a key to a lock, and you can't just use any key. So you've got to have all the right bits in your DNA to live inside of that spider. Otherwise, its immune system will kill you off, or it won't be susceptible to your sting, those kinds of things. So yeah, those fungi, or sometimes bacteria, or viruses or other pests, will have a host that they kind of use them awful mind control. I've seen it in snails as well, and the pathogen actually makes the snail pulsate its eye stalks, and it makes the eye stalks swell up until they're balloon-like, and they've got these insane scintillating colours running up and down them, so that a bird will find them absolutely eye-catching and irresistible, and then the pathogen is inside the bird where it wanted to be. And these are all ecological systems. These interactions of one or more things is ecology at play. And I find that the balance in that dance and the pass-off and the partnership, I find that so dynamic and interesting. So that's kind of why I could never pick a specific insect that was more interesting than how they all fit together, what they eat, how that means that they are only found on, maybe one mountaintop in the specific thing. So that ecology really really interests me. But then insects are just the icing on the cake because they're so weird, so cool, they're so pretty. Yeah. Thank you so much for listening, because without an audience, I just talk to myself, and it's nowhere near as rewarding. And it's a thrill to tell people about insects, but there are ways that they can tell themselves about insects. First and foremost, there are fantastic amateur professional mixed groups. Most places, countrywide, even statewide, Australia, US, Facebook groups where you can join up, log on, post photos if you've got, if you've seen an insect that you're interested in knowing the name of. If anyone happens to be in Tasmania or Australia, I am Shasta Henry, aka the Bug Girl, on Facebook. If anyone wants to send me any questions, I'll go over there and have a look at other questions that I've answered in the past. And if you don't already, then I would encourage you to just, if you see at least an insect, you can type it pretty much verbatim into Google. And I would encourage you to probably put your Google search onto image search to begin with. Your eye and your brain, you're possibly already aware, but it's just the most remarkable piece of fine-tuned imaging and information processing software. I developed this description for my kids in my classroom. But there isn't a microscope and a supercomputer paired together yet that can do a better job of image recognition than you can. So somebody sent me an image one time of a big black wasp that had really shimmery blue wings, and they were interested to know what it was. And so I typed black wasp, blue wings, Brisbane, Australia, into Google image search. And with the barest modicum of scrolling, I was able to find an image that was a really good match. And by clicking through the images, you'll start to find words that allow you to start making a more, honing in your word search. You might find a genus or a family that allows you to kind of start tracking down the insect that you're looking for. So yeah, I'd say, hit Google with a hammer. You don't have to know practically anything to Google up some of your own insect answers.
Awesome. Well, Shasta, thank you very much.
It's a real thrill. Thank you so much for having me on the show.
That was the second and final part of my interview with Shasta Henry, PhD student from the University of Tasmania, talking about her love of insects. Listen next week for Multiple Universes. Unfortunately, the Zoom recording for Shasta's interview didn't work. But you can see many other interviews on the Diffusion YouTube channel. Subscribe and like at youtube.com/c/diffusionradio.
When the moon shall have faded from the sky, and the sun shall shine at noonday a dull cherry red, and the ice cap shall have crept downward to the equator from either pole, when all cities shall have long been dead, and all life shall be on the very verge of extinction on the globe, then on a bit of lichen growing on the bald rocks beside the eternal snows of Panama shall be seated a tiny insect, preening its antennae in the glow of the worn-out sun, representing the sole survivor of animal life in this our Earth, a melancholy bug. It could happen. After all, the odds favor the bug over man by at least 500,000 to 1.
For instance, the descendants of one pair of houseflies, during the 6 months of one spring and summer, would number 191 million, if all of them lived and reproduced normally. That's equivalent to a layer of flies 4.5 feet deep and 300 flies to the cubic inch, covering the entire United States. But only a minute fraction of them survive.
And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions, and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including Radio Blue Mountains 89.1 FM in New South Wales, 8CCC in Alice Springs and Tennant Creek, 2 MVR in Nambucca Valley, 3 MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7 LTN in Launceston, Tasmania, and 2XXFM in Canberra. Diffusion is now narrowcast on Indigo FM 88 in northeast Victoria. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 1,000 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/IanWolf. Support Diffusion by buying from the affiliate links at diffusionradio.com/support. Send an email to science@diffusionradio.com and let me know, would you want to buy Diffusion merchandise? I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits: photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.